Right, well, recovering one of the pulleys, sheaves, whatever the hell you want to call it, went pretty well. This one I had high hopes for, but it broke. It did not break at the weld joint. It broke in the bulk material. I could probably still weld that up again, but I'm going to try a plan B. Actually, this was plan A. Welding it up was plan B. I acquired 2 blocks of Alka 5 cast jig and tool plate, and the reason I did that is like, why in the hell would you buy a piece of square material when you're going to turn it round? Well, because it's half the price of a piece of rod or round bar, and I didn't have anything of the right size for either of these pulley sheaves. So I've got this mounted in my biggest 4-jaw chuck, which as it happens is perfectly sized for it. This is a 1/2 inch longer than the pulley sheave, which is perfect because it leaves me a 1/16 of an inch clearance at the top of the jaw here, so I can hold on to that bottom not required piece and turn everything in one setup, all the pulley features and the bore, and make sure it's all nice and concentric and everything, and then I will remove the bottom piece of material somehow. The option I've got, it will be to hold it on an arbor on the finished bore, just turn it into chips, leave a 1/16 of an inch and come back and face it true and clean. So anyway, there's enough material here to get the 5-inch diameter out of. I centered it up just by measuring, the distance to the edge of the block of material from each jaw, like that. And then I put a center in the tailstock here and checked it after drawing the X on it, and sure, I was right in there. I've got all that's good enough. I don't need to center it better than that, because now I'm going to turn it round and establish everything. But what I am going to do is put a center mark in here so that I can support it with a revolving center for just some additional, pressure against it while I turn everything. So starting off the proceedings by putting a center drill mark in the front of the material and going in with a revolving center to better support it, and that will stay in place for the bulk of the machining. Now obviously this is a very heavy interrupted cut, turning a square block into a round piece, and that's why I'm using this CNMP 431E Valenite insert, which is for non-ferrous materials. These are really tough inserts, and I used this one insert that's on the tool now through the whole process of making this part. It never skipped a beat and held up for the whole duration. Okay, I've set up with a grooving tool here. I'm just touching off on this diameter to establish location and touching off on the face for the same. Now the idea is to use the grooving tool to take out material in the middle of the V-grooves, or where the V-grooves are going to be, just to reduce load on the form tool when I come back and use that. Whew. That piled up on there fast, didn't it?
Way to go, a-hole!
I need to check squareness of the tool post. Right, so after I squared the tool post back up, I went back in and used my better judgment, and I know how to do this, and turned the coolant on. And this is just based on my approach for parting off, which is lock the saddle, half the speed that you would normally turn at, and run some kind of lubricant, whether it's full flood coolant or anchor lube or whatever you choose. And this generally makes for a pleasant parting and or grooving experience, and that's definitely the case here. Worked very well. Okay, the pulley sheaves are roughed in now, and that went really well. Apart from a bit of a whoopsie here with the grooving tool. Totally fine once I applied lubricant to it, which I, should have known better right from the start. And the aluminium forms a built-up edge very quickly running dry on that grooving tool. It's a 140 thou wide grooving tool, so that's pretty hefty load on the machine. But no issue as soon as I put the coolant on. So next stage is going to be to bring these very rough outer diameters to a nicer finish at final dimension, and then put the V's in. Now I've got two ways of doing that. I can use a profile tool, and I know this works. I can get right in to the grooves with this, because I did that on the first sheave, which was a successful repair, and I was able to get right in there and profile the groove sides. And this is a lovely Coromark, which is Sandvik, I think, grooving tool, which I got at auction very inexpensively. I don't often have much luck getting cutting tools at auction. They tend to go for silly money, but I bought a batch of cutting tools, a couple of which I had no use for, and I sent a couple off to another YouTuber who I happen to think is an exceptionally good craftsman, and sold one other one which paid for the entire batch. So I got this for free. Anyway, I can certainly use this to finish the diameters, and if I want to, I can profile the sides with that. I also have this pre-ground form tool, which I've been loaned by a friend of mine who had this groove to repair the sheaves on his Toolmaster that he had. And so this is a simple way of doing it. I think I'm going to try this first. It's a big load. It's quite a large form. But since I've cleared out a lot of the material in the grooves already, I think I can do this. I think my lathe is big enough to handle this. I'll do it at nice low speed, run the coolant, and take my time and see how we go. If this starts chattering and looks iffy, then I can always swap over to this. But this just makes it easy since I've got it. I mean, you know, why not? So we'll start with that. Right, here we are. So step one, I'm going to turn a witness diameter on the face here. I'm not going to take it all the way down because the supporting revolving center is in the way. But I'll turn a little bit back and take off the 50 thou allowance. Then I'm going to do all of these faces, and then I'll come in and do the diameters. I'll get those all to final. You'll notice how rough these are, but that's a result of the roughing work, which got rid of the excess material in a very reasonable amount of time. Now I'm going to do the fine work. Anyway, once that's done, then I'll come in with the V-groove tool and finish it up. I had to take a bath with that lot. Gee, got it all over me. I am not going to be able to get in and do the far groove in this setup like this. So now I have to decide, do I do any of them? Yeah, I may as well, because whatever I do, I've got to re-establish the center line, which shouldn't be difficult. I've got multiple good faces to locate off. So for sure I might as well do the bore in this setup, and therefore I might as well do these three, and I'll just address that one later on a mandrel. It's unfortunate, but that will work. But I didn't know I was going to go this route when I started. Well, it's fine. Alright, but at least I know before attempting to cut it and plunging the tool into the chuck. That'd be awkward, wouldn't it?
One we got.
That's pretty good. Alright, we're going to go with that. The next two, I'm just going to do off camera because it's the same again. So before removing the part to get to the final pulley cone, I've decided to put the bore in place. So this is just a simple matter of drilling out and then boring out accurately. Pretty simple, pretty routine. Final size is just being checked with a gauge pin. Because my planning skills are bad, I ran out of room for the grooving tool, and so I've had to take the setup apart and make a spacer ring to go back here and move the part out. But I wasn't concerned about it because I figure I could dial it back in, and I've done that. And as you can see, there's maybe 5/10 of run out, and that's true on all three of these machine features. So I know this axis is true to the machine, so I can now touch off, reset my locations for this tool and machine the final groove. So let's get groovy. There we go. Now I just have to clean away this bit of material here. Now off camera I drilled and tapped this 1/4-20 hole because I think there's enough footage of 1/4-20 holes being drilled and tapped. That's pretty straightforward. And I've got a piece of steel rod here, a close fit in the bore, and I've drilled a hole into the steel, and I've got a dog point set screw nice and tight in there so that this has good positive drive on that steel shaft. And all I'm going to do is take off this excess material. So I'll take off this square bit and then measure what I've got and face off the last remaining part, and all that will be left then is to broach a keyway. So let's go. Let's make sure that it, well, of course it will, but you know, there we are. It's always good to be sure, isn't it? It's always good to put the lathe in gear too. It's a little bit warm. Okay, broaching. First time ever for me, not the world. So here's the bushing for a 3/4 bore, which is what that is. Here's a 3/16 broach, and this set has been kindly loaned to me by Jim of Jim's Workshop. And if you haven't checked out Jim's Workshop channel yet, then A, shame on you, and B, go and do it after you've watched this. Yeah. So I'm lining it up more or less with the set screw. That's not super critical, but when I want the set screw to come in from this side and essentially push up against the, well, that's just how the original one was. I don't think it actually matters. Now, my good friend Aaron Kohler, who is an actual machinist and knows these things, told me take it steady and use cutting fluid, and so I am going to use cutting fluid in the form of this Hankstoffer's cutting oil, which specifically calls out broaching as one of its excellent lubricant. What's it? slide that under there, and I have a nice bundled up sheet down there, nice and soft, to catch the broach should it fall through. And well, here we go. This has a odd sized bore in it as a result probably of the repairs the previous people did, and because I was trying to work with the pulley as it was, I ended up carrying that shaft size over to this. And anyway, what that means is I cut the end off the old shaft and milled it out and made a custom guide bushing for the broach, which means the broach will be very nicely supported throughout its entire travel. And I'm doing it from this direction so that the material of the sheave, pulley sheave, is fully supported. Yeah. Lovely. Yeah. And you can see the chips all curled up. So there we are. Keyway formed. Now I actually locked this bushing in with the set screw so this won't come out. We'll go over to the bench and do that. And it's now time to actually put some of the head back together. Nice. Well, yeah, of course. That's what spins. And now this is a replacement drawbar that I made. Made that off camera because it's just a piece of turned down rod with single point threads on it.
Just goes there. And that's where the hand wheel goes.
Hand wheel's not ready yet, but don't need that to get this up on the middle and just have a look at general fit. So next thing, can I put belts on it without taking it all apart? So this is a simulated belt change. Why, yes, I can, very easily. And the timing belt goes in from the bottom. Put that on there now while we've got easy access. Thusly. Right, well, let's put this up on the mill. Here we are. So here's the machined sheave all installed with a nice key. Looking forward to trying that. But first things first is just to get that head casting up there with the tensioner and jack assembly. That is just going to run so well. But a few other pieces to finish first. So, wherever this video is at this point, that's the end to it until the next episode. I've got to do some wiring repair here, finish up the crank handle, and then we'll be close to up and running. So, wherever you are in the world, stay safe and well. May your surface finishes be chatter-free and your dimensions in tolerance. Be seeing you.